Okay, so we're on 3.4, and what we're going to be talking about is the title seems to be determined. It's a very interesting title, okay? And later on, you'll understand why it's called that. But let's just start. So in the chat, can you let me know which one of these doesn't belong? And which one of these doesn't belong? Don't think that there's one answer. There's actually several answers, but your job is to kind of argue why you've chosen that one. So what do you think? What do you think? What is the thinking you have? What is the thinking? Okay, very good. So someone says, hey, Ms. Johnson, I think that this one doesn't belong because the equation, right? This equation is like multiplied out as opposed to this one, and these two are graphs. So this one looks different to me. Very good. And then whichever one you chose, good. That is perfect. Okay. All right, so let's move on. It says today what we're going to be able to do is write quadratic functions in Vertex, factored, and standard form. We already know how to do that, right? We're going to be able to find roots of a quadratic function. We already know how to do that. We can use the root of a quadratic function to write the function in factored form. Okay, this one right here is, I think you can figure this one out, but we haven't technically done that. But I know if you thought about it, you'd be able to figure this out too. So this one says, can every quadratic function be written in all three forms of the in all three of the forms we have stated, right? Standard, vertex, and factored. And the answer is yes or no. The next question is, how do solutions of a quadratic relate to the factors of a quadratic function? This is really important. How do the solutions of a quadratic relate to the factors of a quadratic? And some of you already know this answer. That's awesome. And do all quadratic functions have two roots? Do all quadratic functions have two roots? And some of your clues are right in this beginning page here. So let's move on. So Israel and Miriam are working together on a homework assignment. They need to write the equations of quadratic functions from the information given in a table or a graph. At first, this work seems really, really easy. However, as they continue to work on the assignment, the algebra got more challenging and raised some interesting questions that they can't wait to ask their teacher. Work through the following problems from Israel and Miriam's homework and use the information in the table or graph to write the equation of the quadratic function in all three forms. You may start with any form you choose, but you need to find all three equivalent forms. Okay. So there goes that answer for that one of those questions, right? So here, which one, looking at this, standard, factored, or vertex, looking here, would you want to start with? And just as a reminder, I think I'll write all three versions off to the side, just so that you're like, oh, that's what that was. Okay. So in case you forgot, let me put some lines on here because Miss Johnson, she writes crooked sometimes. So just in case you forgot, let's write it over here, right? Standard form looks like this: ax squared plus bx plus c equals to y. Okay, make this a tad smaller. Okay, vertex form looks like this: a parentheses x minus h quantity squared plus k. Oops, that doesn't look like a k. K equals to y. Okay, that's vertex form. And last but not least, our other form, which I will write in this color, is our factored form. So that's a parentheses x minus, oh, what letter will I use there? I will use, they don't use a letter. We're going to use m, and x minus n equals to y. Okay. Notice all three of these all have an A in it, A, and A. His job in all three is exactly the same. His job, A, in all three is exactly the same. His job was to tell you whether he's upside down or right side up and how fat or skinny he is. Okay. And it's not catching up, so there it goes. Okay, so that's supposed to be an N, but it looks like an H, so let me fix that. I don't want anybody to get confused. That's an N. Okay, so which one of these, given this, and this, and this, all this stuff here, which one of these would be the most, which one do you see? Very good. So someone says, let's try vertex form, Miss Johnson. Very good. So if you're going to try vertex form, the very first thing I'm going to do is I'm going to copy this thing over here. I'm going to cheat. I am going to copy, literally copy and paste. I remember telling my students when we were in face-to-face, I'd be like, yeah, then I'd like copy and paste it. And now I can literally do it. Sorry. You're welcome. All right. So the only thing that you need to build vertex form is, guess what? What would you need in order to build vertex form? What do you guys think? What would I need in order to build vertex form? Yeah, I'd need the vertex. Exactly, the vertex. Someone called it the vertex pair. I like that too. So where on my graph is the vertex? Where on my graph is the vertex? So over here, I'll say, this is what we need. We need the vertex. So if you're given the vertex, use the vertex form. Very good. It's the point in the middle, someone says. Someone gave me the exact point and they said -2, -1. So very good. I'm going to graph that right here and say -2, -1. And then I'm going to plug that in over here. So -2, wait a second. Where's the vertex here? What letters represent your vertex here? What letters represent your vertex over here? Very good. H and K. Very good. Someone said X minus H. Part of it, yeah, it's the H and the K. So let me just write that out over here. Your vertex is H comma K. Okay, so that's helpful. So maybe this little thing will be our little notes for this section, and then that'll put it all together for you. So that means my vertex is -2, -1, where this is H and this is K. This is H and this is K. So you want me to just plop it in there, Miss Johnson? Yes, please plop. So A parentheses X minus, and then I'm going to leave some space, parentheses squared, and then leave some space equals to Y. So I'm going to put -2 in for H, -2 in for H, and -1 in for K. A minus a negative is just plus. And if you look, I'm almost done. What's the only other letter that I'm going to need? What's the only other letter that I'm going to need? Very good. I just need A. Ms. Johnson, where do I see A here? Well, A is like your multiplier. And I could tell you right now that, yes, it is X plus 2. Very good. This is going to simplify to X plus 2. So the easiest way for you to grab A, without me going into too much detail on how you could tell, is by just choosing one of these points and then plugging it into our equation so far. Does that make sense? So I'm going to plug it in. So I'm going to simplify first. I'm going to go A parentheses X plus 2 quantity squared -1 equals to Y. And then I'm going to choose a point. I don't care which point you choose. Just give me a point. Which point would you want to use? I'll tell you which one I would want to use. Which point would you want to use? Pick any of these points right here. Yeah. Whichever one you want. So for me, I'm not choosing a negative because Miss Johnson and her negatives, sometimes she makes a little bit careless errors. And here I don't want to choose numbers that are too big because again, Miss Johnson with her careless errors. Exactly. My favorite one to choose is going to be 0, 3. Miss Johnson, why would you choose 0, 3? Because zeros are like almost the easiest to plug in. The only other point that I probably wouldn't plug in would be my vertex because I already used my vertex to build this. Not that you couldn't do it, but I just want to make sure that I'm doing it right. So I'm going to plug in the point 0, 3. I'm going to plug in this point 0, 3. I'm going to put 0 in for x, 3 in for y, and then I'm going to copy the rest of that equation. Okay, 0, 3. Okay. Oh, it's very slow. Here we go. All right, can you imagine that the 0 is here and the 3 is here? Then copy down the rest of the equation to find a. Does that make sense? Give me 1 second. Let me see if I can get this to go faster. Okay, so I put a 0 in for x and a 3 in for y, and then now I'm going to copy the rest of the equation down. So a parentheses plus 2 quantity squared minus 1 equals. And then I'm just going to start simplifying and solving, right? So anybody see anything that I can simplify? Anybody see anything that I can simplify? I'm solving for a, by the way. I'm solving for a. Yeah, 0 plus 2, Miss Johnson. That's 2. Okay, so let me catch up to you. So I got a parentheses 2 squared minus 1 equals to 3. Anybody see anything else you can do? Yeah, 2 squared is 4. So this says 4 times a minus 1 equals to 3. And then I brought you back, right? 4 times a minus 1 equals to 3. I brought you back to like 7th and 8th grade because this is an equation from 7th and 8th grade. What would you do first? Very good. Add 1 to both sides. So we get 4 equals to 4a. So therefore, oh, let me catch up. 4a equals to 4. So therefore, a equals to what, guys? Yeah, 8 equals to 1. So yay, I'm done. Okay, so don't get here and say, oh, I'm done. No, you have to give me your vertex form. So instead of this a right here, I'm going to put a 1. Okay. So let me copy my equation down. So now my final answer is 1 parentheses x plus 2 quantity squared minus 1 equals to y. Here's my vertex form. I'll tell you right now, this is my favorite form to use because I could tell what my vertex is, and that's the most important point on my parabola, right? So Ms. Johnson, did I have to put a 1 there? No, you did not. You did not have to put a 1 there, but I'm putting it there so you all see where it went. Does that make sense? All right, so almost done. So now I am done with this form. Okay. Now I have to find factored form and standard form. The first time through this, it's going to be a lot of work, and then you're going to see, you're going to pick and choose what makes the most sense. So factored form looks like this, right? Does anybody remember what M and N are? What are M and N in this case? If it's factored form, right? What are M and N called? Nope. M and N are your intercepts, x-intercepts. Remember when we would do this before and we would solve for 0 and then we could find our factors by looking at our intercepts? Do you guys all see our intercepts right there? So first thing that I need to find out are what are my intercepts? So what are my intercepts here? What are my x-intercepts, to be specific? What are my x-intercepts? Look here, you have to kind of look really, really small. Yeah, it's -3 and -1. So my x-intercepts are -3 and -1. Okay, so this is how I'm going to build my factored form. It's going to kind of go fast, so pay attention. So the first thing I'm going to do is I'm going to, again, copy this little equation down. Bring it over here. And I'm just going to plop my -3 into my m and my n spot, okay? So here I get a parentheses x minus close open x minus close equals y. And I'm going to take my -3 and my -1. Notice it doesn't matter which way you go, right? And this makes sense because remember when we just solved that equation, it looked like this. And then our answers were opposites of them, right? So x plus 3, x plus 1, and now I just have to find a. And now I just have to find a. Okay, how do I find a? Hey, Miss Johnson, you said that the a was the same in all three. Can I take the a from over here and use it over here? Yes, absolutely. So wait, one more time, Miss Johnson. I just have to find my a. I already found my a for this sequence. Are these a's different? No, their job is exactly the same. That's why I use the same letter every single time. Okay, so I could just put a 1 there and I'm done. Yes. So my final answer is x plus 3, x plus 1 equals y. Everybody okay with that? Any questions so far? Okay, for standard form, I'm just going to tell you, we had this conversation before and we talked about what standard form was really good at. And the only thing that you guys came up with was it was really good at telling me what my y-intercept was. It was really good at telling me what my y-intercept was. And so I know what my y-intercept is, boom, and it's right there. So all I'd have to find is my a and my b, but I have a faster way of showing you. Since this equation and this equation are the same, they're equivalent, I could just multiply out to either one of these to get back to ax squared plus bx plus c. So I'll tell you right now, whenever they give me a graph or a table, I'm probably not going to find me standard form first. I'm probably going to find factored form or vertex form, not standard form first. Okay, so then I would use one of these two to multiply out to get me my standard form. Which one would you rather multiply out? This one or this one? Which one would you rather multiply out? This one, factored form, or this one, vertex form? Yeah, me too. I would choose factored form too. Not because this one looks crazier. It's just I'm used to multiplying these two. So I'm going to multiply these out using the box method. I actually know some of you are able to do this without using the box. Like you could just do this in your head. I'm just going to help out some of our friends who are need a little bit more practice. So x plus 3, x plus 1. So I'm just going to multiply all the way out. Okay. So as soon as this guy shows up, okay, boom. Sometimes when I say boom, it'll show up, but it's not. All right, so there it goes. So it says x plus 3 times x plus 1. And so we're going to start filling in this box. So x times x is what? What is x times x? What goes in? Yes, x squared. Very good. And x times 3 is what? X times 3 is what? 3x. Very good. X times 1. Yep, it's x. And 1 times 3. Yep, it's 3. Very good. You guys are so fast at this. Some of you put the answers in like way before I even asked. So then I'm just going to add this all together. And that's my answer, Miss Johnson. Yes. So here goes. Y equals to x squared plus 4x plus 3. That's what I got. And then I know you guys are going to ask me the question, right? The money question, Ms. Johnson, how do I check my answer? So what I would do to check my answer is I would graph all three of these. And what should happen when I graph all three of these? What should happen when I graph all three of these? So let me start entering them in. So this one's parentheses, x plus 2 quantity squared minus 1. What should happen to all three of these as I enter them in? X squared plus 4x. Someone tell me what should happen as soon as I hit plus 3? What should happen as soon as I hit this 3? Yes, they overlap. They're the same. Are the green and the blue the same? Let's say dun, 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 dun. Yay, they're the same. So far, I know that this and this are the same. So let me enter this last one in just to make sure. X plus 3, close open, x plus 1, close. They're the same, you guys. We did such a great job. Yay. And the crowd goes wild. Okay. But then you're saying, hey, Ms. Johnson, these three are the same, but is this the same as this? So then I would go over here and compare this graph here to this graph. Yeah, it has the same, what is it called? It has the same vertex. Very good. Thanks. And then it has the same intercepts right here at -3 and -1. That's what you guys told me over here. And it has that same y-intercept too at 0, 3. So it has to be correct, right? So yeah, this is well done. So I'm going to have you try your own right here. And that's pretty much it. Okay. The rest of today is going to be you trying all of these here. Okay. Let me see. I'm going to pick one for you though. Which one do I want to do? All right. I want you to try number 3. So right now, I'm going to have you pause and do number 3, and then we'll make another video for this, for our answer for number 3. Very good.